Hey, hello everyone around the world. This is Saturday Science Chats, and you don't want to miss today's episode. We've got our special award winner today, Lifetime Achievement Award winner Nick Percival, and he's going to one of the great stories, and I'm really looking forward to and talking to him about is that there's an institute in Germany that requires it to answer all questions about anything, including relativity, and our awardee took advantage of that, and I'm really looking forward to talking to him about that. But again, you've reached Saturday Science Chats. Yes, you've reached Saturday Science Chats, a special day today. We're going to do these this year. I've been promising these, threatening these for many years, but finally we're going to be doing them, something we've been doing. And unfortunately, some people have even passed that we should have been able to recognize before their lifetime, in their lifetime. But hopefully we're going to be doing that more and more. But today we're going to be awarding Nicholas Percival a Lifetime Achievement Award from the CNPS, and for his work with time. And that, of course, if you don't know about him, maybe you've seen some of them. I think I've had him on this program on our show a couple of times. But that's what we're going to be doing today. So you don't want to miss it. Again, the conversation is going to be absolutely fascinating because I'm going to ask him all kinds of questions, and you can too. We have this is the stuff from last week that has the wrong titles again. Nick Percival, Dr. Glenn Borker, and more. We're going to be doing more as those Lifetime Achievement Awards. And of course, I got the titles mixed up. Every Saturday, we have every other Saturday, we have myself and Dissident Science. That is, we are combining everybody from Dissident Science and the CNPS together. It's over 5,000 subscribers altogether. And we talk about things. And on other Saturdays, we talk about more in-depth topics, just in the CNPS, because again, that's more in-depth, more a little bit nerdier. But those have been going well. So if you make sure you come here every week, because those sessions are absolutely fantastic as well. Of course, you can visit our websites and support us as well. Naturalphilosophy.org is our community. If you go there, it's kind of like a Facebook thing. You can sign up and chat with people about all the things you can't chat anywhere else about science, like, I think the Big Bang is a real problem, or relativity. I've actually looked into it for quite a while, and it's not that not as good as people say it is, and there's a lot of logical problems and etc. There's particle physics, expansion tectonics is also talked about there, and people's own theories. So it's a really great place you can go and meet other people who are real critical thinkers. In my mind, everything is up for grabs at all times. This is not something that, we're going to, we're going to look at this one now, and this one, of course, we can never question. Everything's always questionable. So, and if you are new to this, if you're not like really super nerdy and get into seeing equations and those kinds of things, you can check out our website called beyondmainstream.org. It's our online magazine, which has lots of articles there that are much easier to read for people like science. And you'll also be able to click on things like, come on, there's a problem with the Big Bang? No way. And you can click on a lot of the subjects like the Big Bang, like plate tectonics, like particle physics, like relativity, and you can click on that and then see all the papers and books and people involved with it. We also have a session in there with all the great scientists of our time that work outside the mainstream. So you're saying, well, people outside the mainstream, they're just a bunch of crackpots. No, we have a lot of very amazing, lucid people, some with degrees like PhDs from places like MIT, and like our today's guests from very prestigious universities. I guess you can kind of say that we still have some hope because people like Nick come out of the universities still being a critical thinker, which is great. And we also have a Wikipedia. It's called wiki.naturalphilosophy.org. No, you can't go in and just edit it. It's the kind of the opposite, because if that was allowed, then of course everyone would go in there and trash any idea that was not in the mainstream. So you can check that out. And of course you can support us. That's something we do need. And you can support us by either becoming a monthly member or have an annual membership, or you can donate. And we do get those, and we do greatly appreciate them. We also, once in a while, we get some super chats. That is, if you're watching on YouTube, you can donate money through the super chat system, and that goes all toward our running our organization, which costs almost $3,000 a year just for the internet stuff. That's it. And we had a fundraiser, and I want to thank everybody who participated, but we need to keep going. We can't just do it once a year. And we do have our memberships, an automatic membership system, which costs money. It costs money to have memberships. It's a racket out there. But I do want to thank everybody. And do consider it. $5 a month is not that much if you're on a fixed income. Or maybe even if that's too much, you can do $35 a year, which is even less. But it's all needed and appreciated. And by the way, you can check out yours truly. A great interview that was done only a couple days ago. Oh wow, it's got 500 views well, it was one day ago, but that it was launched. But I talk with these people. It's called the Demystify Sci Podcast. I believe Eric Reeder was also interviewed by that. If you're a person who's a dissonant person, they're always looking to talk about people. Jeez. Whoa, Freudian slip, not talk about people, but talk to people who are critical thinkers outside mainstream. And they dubbed me as, having the Dissident Science YouTube channel and president of the John Chappell Natural Philosophy Society. And that's what I am, and support everybody who's a part of it and all the ideas. We support everybody's ideas as long as they're doing it in a serious manner. And I talked about, my father and I's what we call our 4 universal motions in the universe, and we talk about that. We talk a lot about a lot of things. We talk about, I think I even talked about Nick on there. We also talked about, of course, expansion tectonics, one of my favorite subjects, Einstein being wrong, science in general. What's really nice is when you go to these, they have it really well organized. And please support them. The people who interviewed me and are in charge of the Demystifying Science podcast are Dr. Michael Shiloh DeLay and Dr. Anastasia Benbury, probably is how you pronounce that. They are absolutely amazing critical thinkers. I mean, I was talking about a bunch of things like, there's only pushes in the universe, not pulls. And at first, Michael was like, wait a minute. And then I gave him my dad's, idea of, oh, see that coffee cup? In fact, that's what I did. I said, see your coffee cup in there? Pull it towards you. And that's going to be a pull, right? And he's pulling. He goes, wait a minute. I think you're pushing it from behind with your fingers. And that's, of course, my dad's example. And he was kind of blown away by that. But they really, when you say things, they really take it in and think about it. You can watch them. You can kind of see them. They're really amazing critical thinkers. So if you want, go to the Demystifying Science podcast, go to the YouTube channel, subscribe to them. They do have a Patreon. That's how they're doing their work. And they're just starting to grow their membership. I think they're over 2,000 subscribers now. I know with Dissident Science, I'm coming up to 5,000, but these guys are really serious. They do great work. I believe he teaches. So anyways, check them out. And if you want to be interviewed, send them what you're doing. They may in fact call you in to talk with you. But check that out with the interview. And of course, I have the same thing twice. There you go. Weird. Demystifying Science podcast. This is their... I'm going to have them on, by the way. I talked with them, and they were very willing to come on and just talk science. Talking with them is just a lot of fun. Dr. Michael Shiloh DeLay and Dr. Anastasia Benbury are scientists and explorers. Each week they interview a new theorist about ideas that are going on to rewrite our understanding of nature. So check them out on Patreon at Demystify Sci. Give them your support. They well deserve it. But today we're going to be doing something that our organization proudly does, and that is to give out Lifetime Achievement Awards. And we have a lot to give out this year. I really need to focus in on this. We've had some people pass away, like Dr. Edward Dowdy, who absolutely should have been recognized. And I just kick myself around for that. But again, we don't have a lot of people have the ability to run this organization, so I can't get myself too bunched up about it. But we do have other people I've already talked to. Our next person coming up is going to be the great Dr. Glenn Borker. So many people's work has been resting on his shoulders, as well as Nick Percival, and his work with time. Some of the past recipients, pretty big names in our community, of course, Halton Arp. He is the Strange Galaxies, a dissident scientist, if you want to say, but what we call critical thinkers, who was actually drummed out for finding stuff that didn't fit the narrative of the Big Bang and Redshift. Ron Hatch, who was a great friend, he was a GPS satellite engineer. Became wealthy with that. He became his company was bought out by, I think, John Deere, and he said he wanted to retire, but they gave him such a great offer for the money for he sold me the salary that he couldn't refuse. He's in my film Einstein Wrong, and in the film I asked him for one statement about GPS and relativity, and he said this is what I want to say. He says, GPS does not support relativity, it points out its flaws. Another recent recipient is Dr. Bill Lucas. He is a really brilliant mind who came up with the universal force equation. Again, equations that describe the force and he unifies a lot of the forces, which is a lot of people's goals. It is pretty big, the equation, but again, he is a really brilliant mind. I really enjoyed it, and well deserving of this award. Dr. Ebely Spencer, who was president of this organization when it had a different name for many years. She is a doctor in mathematics. She got it in the 1940s during World War II as a woman. Quite amazing. And her work with relativity. She was an anti-etherist. I wish she was around because, unfortunately, I will say I don't believe ether. I think there's just way too many problems with it. But it was funny at a time 20 years ago in our organization, being an etherist, you were frowned upon. But today, ether's everything, even though there's a lot of problems with it. But again, it's interesting. I remember these people and their impact on work outside of the mainstream. And she was absolutely fascinating and amazing person. And of course, Dr. James Maxlow, who in my opinion is the greatest geologist who has ever lived. You can read his book. He was honored at the University of Vancouver and Canada. And I remember that so well. It was the first time I met him. He is just an amazing person. And also Walt Thornhill, for I know there are a lot of people watch Channel R from the Electric Universe. And of course, he is the guy in Electric Universe, and we gave him the award, I think, in Albuquerque, New Mexico. Flagstaff? No, I think Albuquerque. Flagstaff is where I went to the first meeting of the CNPS in '96. Okay, yeah, get my stuff straight. But Walt Thornhill is another person. So Nick, there are more too. I just couldn't remember them all. But he's standing in some big time quarters. So let's talk a little bit about Nick Percival. He was born in the Boston area. He's 80 years old. He entered Harvard in 1960 and graduated with a degree in theoretical physics. That's amazing, from Harvard. So those people who are saying are all of us quote unquote crackpots don't graduate from distinguished universities with degrees in physics. Whoops. He and, another award recipient, Lifetime Award, Dr. Cynthia Whitney. She had her degree, PhD in special relativity from MIT. And she tried to apply it. Of course, you know the story. And it didn't work with the ring gyroscopes. So, yep, very impressive. You don't do that easily, so obviously very bright person. And a little bit about him. After the Army Reserves, he went to Brazil with a Brazilian-born Army buddy. Went to Belo Horizonte e Visconde de Rio Branco, and then to Rio de Janeiro. I'm saying this because I'm trying to see if he I wonder if he speaks Portuguese. I don't speak Portuguese with him. Probably say, no, I forgot it all. But he worked in South America's largest English language newspaper and the sports editor for baseball, cricket, Reuters. Wow, I didn't know. He and I have that in common. In 1997, I went to Brazil to live there, and I lived there 3 years, from 97 till 1990. So we have that in common. And he joined IBM in July 1965, worked in systems development. Well, a software engineer guy. Wrote Checkpoint Restart for all 3 versions of System 360 and 360 assembly language. Man, that was my first job, watching bits, 8 bits, binary bits move up and down. And I was working at an 8-bit register, so he's a bit older than me, but still. No bugs were found by the test team. Wow, won 3 outstanding contribution awards. Man, my dad worked on the Univac computer that had tubes. So just great history here. Went back to the Boston area, IBM marketing division as systems engineer, won best systems engineer in the country in the insurance industry out of 600 insurance SEAs. I can't imagine not. Received a sailboat, cash and a silver cup. Man, you can see I've had time to read all this, but that is so cool. Received a sailboat. Man, how many people received a sailboat? What do we get? We get an Amazon card. No, my company is actually very good. We get bonuses every year. I love my company, actually. Work for LexisNexis. You want to work for a company that cares about its employees? That's one of them. Nick Percival, he studied special relativity and the twin paradox after Harvard in my spare time. And it seemed like, you can see he wrote this, trying to make it into the third person. It seemed like an unsolved problem. It seemed that way. You think? Eventually learned about Dingle and dissident scientists. Very interesting. His first published paper was in Skeptical. That's his. So you can see I've edited this, but didn't get everybody switched in their person. But his first published paper was in Skeptical Inquirer, and then Physics Essays. Physics Essays is pretty well known. Eventually, Greg Volk brought him into the MPA. Again, that was the name of our organization before this. And he met me, and the rest is history, as he says. But if you don't know about Hick, I called him Hick. Nick, gee whiz, where did that come from? He's about as far from a hick that I would ever imagine. But Nicholas, we call him the Nick of Time. You're a time guru, saving science souls in the nick of time. If you haven't seen his YouTube channel, it's growing. And he actually puts some videos on there once in a while with his buddies out there. He does that because he is obviously a software guru or software savvy. And this is the banner from his Nick of Time YouTube channel. You can get to it by a couple ways, actually. You can go to youtube.nickoftime.guru. He has a website, nickoftime.guru. Of course, you can get there. You can also go to nick.naturalphilosophy.org. I have that pointed to him as well. So either way, you can get to know his work. It's really great. I interviewed him a couple times, but this is probably my favorite of all. And that is his, I'm not sure it's the last time I did talk with him, but he said a surprise ending, the history of time, with the surprise ending, Nicholas Percival. And if you haven't checked that out, it's a great one. His presentation, I love that presentation. I think I've even got some things here. One of the things I like that in that presentation is the banana test. This is kind of something that I kind of came up with in my own, not the banana, but just freezing people, like the twins paradox. When people talk about, oh yeah, time slows down, I go, well, okay, is it time slowing down or is the clock slowing down? And movement is just changed. Our way of measuring it changes because the clock is changing physically. And they go, well, I don't know. I said, okay, how about this? If I freeze mine was, if you freeze one of the twins and then put him in a freezer, like he does a banana test, and then 100 years later, his other twins died, but he's still around. So time slowed down for that person in a kind of, say, colloquial sense. So it's kind of the same here. He has the banana test with 2 equally ripe bananas, one in the freezer, one outside, examined in 2 months. Possible conclusions. Time is slower in the freezer. That's very relativistic. Or the cold slowed down the decay rate. Wonder which one is true. And people kind of get that, and then they start thinking, yeah, maybe time slowing down is kind of a absurd idea. Some other things that he says in this is that we need an accurate physical model, which I think that's very interesting. I agree with him 100%. I think our entire problem with like even quantum mechanics is we don't try to come up with physical models for anything going on. We're using magnetism, we're using gravity, we're using light, and we have no physical model from it. Doesn't mean that people don't have physical models. They do exist, but people outside of mainstream. And the other thing is SRs, I love this too. Special relativity's model for 4D space requires thinking of time as a physical dimension. And I do talk about that a lot myself. So I just thought those was so cool. But we're going to be talking to Nick very soon here. But even though this is not official, and we're going to be sending you, Nick, of course, official big ass frame, beautifully framed with this on it. But today you get a PowerPoint slide. But I do want, as the president of the CNPS, I want to congratulate Nicholas Percival for his for your decades of work on time, special relativity, and the twin paradox. Your work sheds light on a very important and difficult subject in physics, and that is time. And yes, I will put the determiner A in there, which I forgot. I sort of made that picture in this swirly thing because it makes you look like you're important, and I pulled you off the £1 bill from Brazil because you are now so famous they put you on money. So I guess that's the ultimate of famous or infamous. But again, everybody, please congratulate Nick. Send him congratulations for this. Well deserves. And we will be putting up, one of the things we're going to be doing is putting up on our website a page of all the winners. We used to have that, but between this trade moving and servers and all that, fortunately we lost some of that, and but we're going to be recreating that because we are doing this now again. So expect to see these all our winners on a page sometime this year. And Nick, you can expect in the near future your certificate to hang proudly on the wall so that you can hang it on your bookcase behind you. So I do have some questions for you, but I'm not going to get to those right now. But what I want to do is bring up the person of the hour. Hopefully we got everything worked out and we can hear you. How are you, Nick? Can we hear you?
Testing 1, 2, 3.
Oh, yes, testing really great. Well, first of all, before you say anything, I do want to congratulate you. This is well deserved. I've talked to numerous other people in this organization, and none of them said, "Oh no, not Nick." They all agree that your work over the decades has been quite important to we. In the dissident community, because no one has really taken the time and effort to look into time and relativity the way you have and really bring us some really clear understandings of a subject everyone talks about, but no one really puts there. So congratulations.
You misspoke. I didn't take the time. I took the proper number of process cycles to
That's true.
investigate it.
Right.
Even I can't get rid of the word time. So
Yeah, it's hard because it's like anything in the words. You have to understand what context words are, right? When you talk about time in a physical manner. So I have a bunch of questions for you, but I think the first question I always give all of people that I talk to or interview who are the award winners, even if it's in front of a group. A lot of times we have a person sit in front of our live groups and we talk. How did you get into all this? I mean, obviously you had a degree from Harvard, very prestigious degree in physics. Why did this? What did it? What made you turn in this direction? What led you astray? No, not astray. But what? How did that happen?
Well, when I entered Harvard, my one assumption about physics was that the physics professors were the smartest people in the world, and everything they said had been proven by the empirical evidence down to 9 decimal points. So I really went along accepting uh, whatever they said. But the interesting thing was when they presented special relativity, without thinking about it, I didn't accept the accepted uh, uh, interpretation of special relativity because I just knew it was obvious that had major flaws in it. And I say it's obvious. I'm not trying to say that I'm particularly smart in that area. All you need is high school algebra, and thousands of people have had the same reaction that, if you take special relativity literally, then you come to the conclusion that A's clock is slower than B's clock, and B's clock is slower than A's clock, which is more than being counterintuitive, that's counterlogical. Anyways, I'd always liked and was good at abstract thinking like math and physics, but it seemed to me that all of the problems, based on my assumption that whatever the physics professor said was right, was indeed right, that physics had been investigated for 2,000 years, so, it's pretty well mapped out. Whereas computer technology was something new, and I also liked it because it was abstract logic. So I decided to go off into abstract logic. And just one final point was really the turning point in my life was I was talking to a professor, and I had seen in Life magazine them talking about the astronauts and saying that because the astronauts would be going at high speed for some time, when they came back, they'd actually be younger than if they had a twin on the Earth. And I laughed. I said to my professor, I said, "Can you write to these idiot journalists who know nothing about science and correct them?" I mean, obviously that would be a contradiction, logical contradiction. And we talked about it for a while. And I thought I gave him my arguments why I was wrong, and he didn't come back with any counter argument. So I assumed that my professors knew better than Life magazine. So I left. But after I left, I began to see that the academic physics world was taking an interpretation that special relativity was describing the physics world, what was happening physically. And I knew that was wrong. So, I have kind of a theory that a lot of people are called gifted. I think it's simply that gifted people can just become very passionate about one thing or the other, and then the mind is molded to be an expert in that particular area or whatever. Anyways, I got hooked. It was like an addiction. I saw that this thing was wrong. I was sort of like an activist who sees something wrong in politics or government or corporations, and it just had to be set right because the first 20 years or so of looking into this and trying to discuss it with professors or whatever, you're all alone. You're kind of voiceless. You have zero economic compensation. In fact, you have to outlay money. There's certainly no fame. That's why it's very nice at the age of 80 to finally get some recognition. Thank you, David, and the CNPS. I was expecting a motorboat, but anyway. So that was the switch, and it's kind of interesting. In quantum mechanics, they say the trajectory of any individual particle is probabilistic and can go off in any wild direction. But here, because I kind of misunderstood my professor when I was trying to convince him that special relativity wasn't predicting real physical slowing, um, that just that misunderstanding of maybe a word or two sent me off onto a totally different career path, ending up in a different city, um, changing who I was married to, and obviously who my kids were. I can't think of anything that would be more life changing than that, and yet it would all hinge on just how a single word was spoken or misinterpreted. That's a long answer.
Well, that's good. No problem. There is a question here in the chat that says, "Does he still have the sailboat?"
Yeah. Oh, actually, I had it for many decades, and then I moved away from the water. So the person who was letting me use their dock, left it that to them in payment for the many years that they had allowed me to use their dock.
Oh, that's okay. All right, that's good. So, when you started doing this, you were you on your own? Did you have anybody you were conversing with, or did you have a group of people, or were you
I
pretty
was
much on your own?
I was on my own really until Greg Volk brought me into the NPA. But um, before that, I published something, and I think the title of the journal at that time was the Skeptical Inquirer. I may have gotten that mixed up with the Philadelphia Inquirer. I don't know. And in 1992, I wrote an article that was accepted by Physics Essays. But
Right.
basically, it was pretty much just on my own thinking about this problem.
Wow.
And in
And that's
fact,
a long time.
interestingly, Harvard you think of as having a great education, and several of the professors there had won Nobel Prizes, and a couple more won Nobel Prizes later. But when they taught special relativity, they didn't even mention the twin paradox,
Hmm.
much less talk about Dingle or some other people who had different ideas.
So you had mentioned that you've discovered Dingle. Was that really pretty early on? And how did you discover that? How did you become aware of that? If you're all on your by yourself.
Yeah, um, I can remember individual memories pretty well all the way back, but I can't always remember the year that happened. But I would say there was at least 10 years before I heard of Dingle, because it would just myself. My only contact would have been with physics professors occasionally who would just say, "Oh, you don't understand special relativity," and that would be about it. So
So but Dingle. Tell for people who don't know who Dingle is. Won't you explain a little bit into your knowledge and what was important to you about finding his work?
well, if I'd found it in, say, the first year after I left Harvard, or even at Harvard, then I probably would not have gone this course, because I would have said, "Oh, here's somebody who's was a very well respected physicist. He had written a textbook on relativity, and until he said, 'Hey, there's something wrong here in the I see in the twin paradox, that our current interpretation of special relativity is clearly wrong because it leads to a very simple, obvious um, logical contradiction.'" Uh, but I didn't find it for 10 years, and by that time I was already hooked. So that did not allow me to forget about the twin paradox problem and what was wrong with currently accepted theory.
So do you think that Dingle's work still holds today?
Oh, yes. Yeah, it still holds today. In fact, there was a professor at Harvard, Professor, I think, Hasok Chang, who went over to, I believe it was Oxford or Cambridge, and he studied the history of science. And he wrote a long paper about the history of the twin paradox. And he was relativist, so he wasn't biased against Dingle, but his conclusion was that Dingle had raised questions that were never addressed by the people who debated against him,
Hmm. Hmm.
which was quite a statement, quite a
So,
finding.
so this is a book. I think it is. It's showing a sample of the hardcover edition of 1922. So 1922, this is really contemporary relativity. I mean, 1919 was the Eddington putting Einstein on a pedestal with kind of suspect data.
Yeah.
From, and he was a celebrity by then, but it looks like you can still get some of these. I'm not sure, but I think I have. Yeah, but I think it's forgotten. It says forgotten books,
That that
relativity
that,
for all.
that was well before he discovered the twin paradox problem.
Right? Did he?
I
Did,
don't
did
think
he?
it came out until about 1930 that he really became an activist and wrote his famous book on that.
Right now, I wonder if that. Do you remember the title of that book?
Well, I actually have it somewhere, but I don't.
Right, right.
I could look it up on the internet and look up Dingle and it'll tell me.
The Theory of Special Relativity. When was that published? 1950 by Herbert Dingle.
Yeah, that was well into the debate, but
Right, right. And they are, man, they got people selling it
but
original
but
copies. So,
but I think his more famous book is a different title. I can't remember.
yeah, I'm just trying to find to see if anybody can find that in the chat. Let us know. But okay, so you got Dingle, and you were saying that you already were sort of convinced by it, but Dingle, it was sort of, he had the same, I think, fate more or less as Samuel Warren Carey did in the Expanding Earth realm. He was respected, Samuel Warren Carey, for his scientific work in geology, but he was kind of looked at kind of sideways when it came to his idea that the Earth was expanding. Dingle, though, was out there really fisticuffs and fighting, right?
Yeah, but before he did that, he was very well respected as a
Yeah.
leading proponent of relativity and a leading authority on relativity.
Wow.
So,
So that kind of changed.
yes.
Yeah, it's funny to listen to the change stories from people because each person has a change story. With James Maxlow, he was it was the same kind as Dingle. He was a geologist, and Samuel Warren Carey said, hey, "Here, take the baton. I'm getting old." And James said, what do I know about it? And he was studying everything, and he said it was the plotting of the South Pole, from which wanders from the middle of the bottom of Africa to where it is now. And then when he plotted it on an expanding Earth, it fit perfectly. So that was his turning point. He said, once I saw that, I understood. It sounds like you didn't have necessarily a turning point at any time. Oh, wait a minute. I think we do have maybe a title, or Science at the Crossroads.
Yes, that's the famous book.
Thank you, everybody in the chat. Thanks, Shockwave. Thanks. I think also Franklin probably looked it up. That's one of the things I got to remember. We've got all kinds of, we got a lot of producers who are watching live who can get you answers more quickly than, but so
Which is very helpful when one's 80 years old.
yes, I'm 63, but I have no excuses yet. But okay, now you said you wrote papers. I think it's one of the things that probably more fascinating about your story is most people, when they get to something and they're passionate about it, they want to reach out to others and tell other people. It sounds like somewhat you were to yourself and it was an interesting problem, but you didn't sound like you were out there wanting to shout it from the rooftops, or am I reading that wrong, or were you?
I guess I wanted to shout it to the rooftops, but in those days, if you were a dissident, you were pretty much a lonely person, um, and you just were voiceless. And maybe it was my fault for not finding the necessary connections earlier. Um, Certainly, I think that physics essays has done a wonderful job for dissidents
Yes.
and has
Yeah.
been a great force for progress by
Mhm.
dissidents in physics.
Hmm.
But they weren't around when I graduated,
Right,
and it
right.
took a while for them for that. So there was a skeptical inquirer, but it didn't have a very good reputation. So even though it got published, didn't really get known widely.
Right. I think I've found this now. Let me put this on the screen. Here it is. Herbert Dingle's Science at the Crossroad, a rational scrutiny of the clock paradox in Einstein's relativity. Now, I want you to talk a little bit about that. One of the things that people really, like must know, is that people really have a misunderstanding of what the twin paradox is. They just know they know the kind of colloquial story where one stays on Earth, one travels toward the speed of light and comes back, and there's a change in age. You were fascinated by this, and so was Dingle. So you read, I would imagine you read this book at some time, and that got you on to specifically the twin paradox. And what was so fascinating to you about the twin paradox? Why? I mean, obviously, there are a lot of things you can spend on special relativity that have nothing to do with the twin paradox, but that really kind of caught your attention. What was that, and how did that come about?
Well, let me go back to what I said earlier. I believed what the professors were teaching me, but my mind wouldn't accept the twin paradox, the interpretation that time dilation was talking about physical slowing of clocks and other things, because it's a symmetric equation. It says that A will perceive and measure clock slowing for B, but if you apply it consistently, then uh, special relativity should be showing that B will perceive clock slowing for A. So obviously, to my mind, without thinking about it at all, that must have been a just observed effect. It couldn't be physical. If you apply the relativity principle that all frames are uh, all inertial frames are equivalent and you can't distinguish one from the other, because obviously if it was velocity with respect to A and just A, then that would be a physical effect. But it can't be a physical effect of velocity with respect to each and every inertial frame. Anyway, so that's what got me interested in the twin paradox even before I heard the twin paradox. And as I say, I read about it in Life magazine for the first time because it wasn't taught in Harvard. And I could see that that was, attributing uh, slowing down of aging to special relativity just didn't make sense. So it was that was the turning point when I read Life magazine and realized that special relativity was being interpreted differently than I thought it was.
Now we know the explanation for general, of why we would be able to tell one twin changing versus the other, and that has to do with introducing general relativity and acceleration. So, do you have some kind of explanation for their quasi explanation for being able to distinguish where you're saying it's symmetrical, right?
Yes.
If two people are traveling at there's a velocity between those people, who's moving and who's not. So whose clock would be moving and who's not? Would they be, that kind of thing? But their standard mainstream answer is, oh, that's because Einstein wasn't done. He had general relativity, and that solved the problem. What's your take to that argument?
Well, as we just said, the problem was that there was symmetry. When you're talking about relative velocity, um, A has relative velocity with respect to B, and B has relative velocity to A. So if clock slowing is equated to relative velocity, then you have symmetry between the two. Even if one sees a different relative velocity, they both would see the other clock slowing. And what the relativists at least took step one and saw that that was a problem. So they introduced an ad hoc solution, and that ad hoc was to add some kind of asymmetry. And the one they thought about was acceleration. And this is fairly typical of relativistic reconciliation arguments, in that if something sounds plausible and at first glance can't be dismissed, then they just accept it. In fact, in the twin paradox literature, there are more than a dozen different explanations for why clock are slowing, but they all contradict one another, so they can't all be true. Otherwise, the clocks would be slowing by a factor of 12. So it really was an ad hoc device to introduce an asymmetry, because in the development of special relativity, there is, or in the assumptions of special relativity, there is nothing that would lead to concluding that acceleration would make you dismiss special relativity and you could no longer use special relativity. And if you really thought about that argument, that if you introduce special relativity, then you can't introduce acceleration, then you can't use special relativity, it means that special relativity can't be used by anybody, because no one is in a perfect inertial frame, and B, even if they are now in a perfect inertial frame, at some point in their life they would have accelerated.
Yeah, there are just so many problems. Yeah, go ahead.
Third, we can introduce and develop twin paradox scenarios where there is no acceleration. Just to give you a hint of how you do that, is you say that A and B are in two different inertial frames, and A and B pass arbitrarily close to each other, so there's no question about simultaneity, and they check their clocks as they pass by arbitrarily closely. So now at the start, you don't know which is going to be the traveling twin and which one is going to be the stay-at-home twin. And if relative velocity is the change, that means there's no way to get out of that problem, because if you decide later on which twin is going to do the turnaround, then you can't explain what happened on the where they were departing, where they were separating.
Yeah, I mean, go ahead.
So there are multiple very powerful arguments about the alleged reconciliation by using symmetry. And in fact, if you look at Thorne and Wheeler's Bible called Gravitation, on page 1055, they say that it's the slowing of particle decay is dependent on one thing: instantaneous velocity. The acceleration, how much when it's done, has no effect on the clock slowing, other than how it changes instantaneous velocity. So really, particle accelerators, which are supposed to have proved and be based on special relativity, disprove that argument.
Yeah. Special relativity and particle accelerators, they've got not a great history together. In my film, of course, I talked to a experimentalist, and he said to me, I have to unteach special relativity to my grad students. And yet that's happening in the real world for experimentalists, people who at least are trying to do real things, physical things, even though what's actually smashing apart, no. But The problem, of course, with particle accelerators is they use the relativistic equations.
Right, but not the relativistic model.
Yes. And so you end up with things like, the neutrino, all these ideas that, we're using this equation, even though we don't use the model, we're using the equations that introduce, because of speed, extra energy, quote unquote. And therefore that has to be taken away. And then they invent something to take away. So it's like we've added something extra with no explanation, no physical explanation, even no philosophical or logical explanation. And on top of that, we're going to take it away with a magic particle at first that didn't have mass or charge or anything. And this is just part of the game and push me, pull me. It's almost like, I don't know, you remember that I seeing like this horse that has two heads with a body and they're facing opposite directions. I think that's kind of the way what special if special relativity were an animal, that's what it would be. You can't move. And the other thing too is when I was first thinking of this, I always said, okay, I always talk to people. I go, okay, you special relativity, right? The twins. So let's imagine in this experiment that you get rid of the entire universe except for me and you, and we can see each other. We're lighted, and we can see each other. Well, of course, then you have light, but that's the way it is. And there is a distance between us that's changing. The question is how fast are you moving and how fast am I moving? And they think about it and they go, oh yeah, because when you're standing on the earth and somebody's in a car, you're going, they're moving at 60 miles an hour. No, the velocity between you is 60 miles an hour. Now, one of the things I think I remember from many of your talks, it seems like you talked about more of like science and physics. Yeah, you need physicality, but also a locality. That things really are more around what's happening around you. And did you talk about something like that, where what velocity really is, how we really should use it?
Right. Now, poor Albert Einstein got a bad reputation, but, he really didn't do anything wrong. The blame shouldn't be focused on him. He was thinking and throwing out ideas, and they were immediately grabbed up and not really critically thought through and accepted. Einstein himself, in 1916, basically implied that he was recanting on his twin paradox claim. And an author whose name I can't pronounce detailed that whole process that went into his mind. And he eventually took the criticism, the early criticism of his special relativity claim, and was converted by it. But the rest of physics A didn't think critically enough about his original thesis. And even though they sort of worshipped Einstein, they didn't follow Einstein when he saw that there was a problem with his twin paradox claim and how physics was currently interpreting the physical meaning of time dilation equation. But Einstein was always changing and always receptive and always thought about criticism. It's just that the rest of his colleagues didn't. And one of the things that he said is all physics is local, which basically means it's the interaction of two physical entities that describes what's happening physically. And that's something that's been a great guidance to me, to think in terms of what's happening physically. Now,
so locality, the local and physicality are absolutely related then.
Absolutely, absolutely. And one thing about relative velocity, we were, with astronomers and cosmologists are looking at light from, say, a sun that was available or was in existence 5 billion years ago, and it sends out light. And the redshift is interpreted when it reaches Earth as a function of relative velocity. But let's say that when the light was emitted 5 billion years away from Earth, Earth didn't exist. And that shortly after the sun emitted that light, it went into supernova and didn't exist anymore. So what is the meaning of relative velocity when something that really is separated? Because here you're talking about the relative velocity between two things that didn't exist at the same time. And Professor Dingle showed that relativistic velocity can be shown to be equivalent to taking the velocity of light relative to the preferred frame of the sun, and the velocity of the at its reception, the velocity that it's being received at relative to its preferred frame. And that's how, from those two things that are local, you can derive the relative velocity between two distant things.
I never thought of that. I never thought of sun 5 billion miles away, 5 million light years away, and that when it emits it, it's gone. Where it's sending to it isn't there yet.
Yes.
And then so you're what does it even mean to that is just that's a perfect example of what you're talking about, physicality and locality.
Yes.
And the other thing too about all of this is I see some people putting some comments. I'll bring them up, some interesting comments. But one of the things that I've kind of, since I met Lori Gardee in 2017 or something like that in Vancouver, one of our conferences, she was what she calls her the fractal woman. Very interesting person and very interesting work. One of the things is when you look at the physical world and you see like a circle, a real circle, like a hula hoop, and you go, okay, the hula hoop has this radius, and therefore the length around the circle is this much by an equation. But if you go down further, and then you start to see that the hula hoop is not a perfect circle, that all of a sudden you would add, and it's like the same, I've heard the same thing said about the border, the length of the border of a map, like the United States or something like that. You can draw it, and depending on the, resolution of what you're doing, that number changes, can be drastic. And then when you get down to a certain level, it becomes almost infinite. And what happens is, it makes you think, especially because I'm a believer in Borker's infinite universe theory, that you can't have partless parts. Every body is a body of something else. When you look at that and it goes all the way down and all the way up, what we see is a locality of something, because we don't see all the atoms and we don't see all its bonds. We see some level. And then if we pull back, we see another level. And it's so, I think there's also not only the closeness of it, but there's also a locality physically of kind of the level and resolution you're looking at. And I think that's kind of related. It's a different idea, but it's also related. So I think, the idea that we need to deal physically in our local world is absolutely right, because you'll never, if you try to go beyond local, you go loco, right? So that is, I think, extremely interesting. Here's a question. It's for, I think, from one of my people, but I think it's interesting, and that is, what do scientists mean when they claim to have proved the universe isn't local?
I don't know What do you mean it isn't local? I don't.
Yeah, I guess people are saying that people have claimed the universe isn't a local phenomenon. I'm not sure either with that. I've heard of that, but maybe a person can explain that. But anyways, I thought that was I read that wrong. I think the first time, but maybe that person can explain what they mean by the locality. But no, I think that's the physicality gets us in trouble. I think it's interesting to me, and we talked about this before, but I'll bring it up again, is how a person like myself and my father, who were just tired of equations for physics for electronics, right? You got all your electronic current and resistance and all those things, and wanting to really know what's really going on with light, with magnetism, and all that. That brought us to what we came up with these four, universal motions. You came from looking at relativity and came to a very similar conclusion that we need to think physically.
Yeah.
And now that to me is fascinating, because one, to me, is I just don't believe in magic. You can't put a plus sign over here and a minus sign over there, and protons and electrons magically start attracting. What do you think led you to the idea? Was it thought experiments like the sun 5 billion light years away that led you to this conclusion? How did you get to that conclusion? It's very different from my father and I's angle, for instance.
Well, I know that reading Einstein's words about all physics is local really did have impact on me. It just made a lot of sense that it's the interaction between two or more physical entities that causes things to happen. And thinking about trying to address the thing about why relative velocity, as used in special relativity, was flawed. It just led to thinking about that and came up with that example about light from a star that's 5 billion years old and 5 billion light years away. It just showed that was magic, that it really wasn't relative velocity that was the key there.
Okay, yeah, I think this person did say something. It says the universe is not locally real. There was the Nobel Prize in physics for that. And let me see who. Yeah, here it is. I can put that on the screen. I guess you have the universe is not locally real, and the physics Nobel Prize winners proved it. I love proof. There is no proof, obviously. Right. What you have is equation.
Evidence.
Exactly. You can have supporting evidence for any theory, but you never can prove it. But it says elegant experiments with entangled. Oh my gosh, there you go. Entangled light have laid bare a profound mystery of the heart of reality. Oh boy. Yeah, this comes from, in my opinion, this comes from exactly the problem of not having physical explanations, right? When I talk to people who are not so, obviously the people watching this are probably, and most likely, much more well-read in this area and thought a lot more about it. But people who aren't, I always say to them, okay, they go, where's this coming from? Particle in two places. I said, no, what's happening is they are guessing what they're doing without having any physical model for what they're doing. So when they say to the world, I'm shooting one particle at something, they're not doing that. Because if they were, and they were really had something, we would find one particle on the other side. So or something else is happening without any physicality, and them making assumptions about the physicality which are wrong, whatever they may be. Maybe it is one particle and there's other things happening. You end up with these absurd conclusions. And of course, the absurd conclusions are mysterious. They make your mind bend and break, right? And it's entertaining because our neural networks like to see new things. They what makes us laugh are, or surprised are new things. And so these kinds of things, that is the experiments with entangled light. We don't even know what light is. How are we entangling it?
Yeah, I think some physicists got entangled in quantum mechanics.
Very good. Very good. All right. So we do have a green room. So people who would like to come on and talk with Nick, or even congratulate him. I do see we have people in the green room. You can come live with us. You don't even have to appear with your video. You can keep your video off if you want, but you can come on. Just go to any browser and type in live.naturalphilosophy.org. I change that every week to point to our StreamYard broadcast here, so you can do that. I know we do have some people in our green room. I see they've turned off their videos, but
look, shall we talk about time for a while?
oh yeah, well we do. I'm just inviting people because I know it takes
Yeah.
some time to get here. And also the two things I want to talk about is time, but the other thing I do want to talk about, we have a lot of time. We still have an hour of time, quote unquote. The two things is to talk about time, and the second one is to talk about your interactions with the Institute of whatever in Einstein in Germany. I think that's a fascinating story. We'll leave that till later, but let's talk about time. Time is one of those things when you look at people try to define it. Borker has probably the shortest answer to what time is, and he makes it equivalent to another one word, which is movement. And in some sense, yes, time that we talk about is related to movement. We need time to, I guess, talk about movement, and so we have that concept. What is it that you have found over so many decades that what you talk about time? What is that in your mind?
Well, I've been at this for 60 years, and I was focusing on the twin paradox, and that was the question that Einstein claimed that a clock would slow down as its velocity increased with respect to each and every inertial frame. So that was a concept of proper time, as it's called in physics, which just literally means clock time. The time between event one, where the clock is at event one, and the time at event two, and you subtract the former from the latter, and that's the amount of proper time that expired between those two events. So that's an observer independent concept, and it's absolute. And any theory that says that proper time is observer dependent is wrong, because it has to, by definition, it's operationally defined, and there's only one possible answer. So that's what got me interested in time. And as I thought about time in physics, it just didn't seem to be treating time properly. And I read a book by, I got it here, Lee Smolin, Time Reborn, and he criticized physics. He said that even Newton, tended to get rid of some of the essential properties of time, and that special relativity took it one step further and really got rid of it. There was no past, future, or present. It was just time was another dimension. You could travel that along that timeline. But it seemed to me that the concept of proper time was, because it was observer independent and defined operationally, was a much better foundational construct for dealing in physics. But then I realized that in a clock, the display is in human terms of what we call hours, minutes, and seconds. But the fundamental mechanism is some physical process that's very stable. So, what a clock really measures is the number of cycles in a process, particularly a very stable process. So then it suddenly hit me after, 50 plus years of, well, I'm a fast learner. It only took me about 50 years to realize that time doesn't physically exist. I'm slightly different than Borker, but I think we're thinking similarly. That I say what time really is process length, and processes are moving within three-dimensional space. They don't have a separate dimension unto themselves. And this goes for all processes, but processes that are stable and tick, tick, tick are useful as defining a standard so that we can compare the unfolding and the length of one process versus the unfolding and length of another process. So I say that process length is the fundamental thing that's happening physically, and time is an emergent property. And it's a wonderful human construct that makes thinking about things much simpler. It's a simple generalization, and basically it defines a standard by which we compare every other action and process that's going on. And it started off by people talking about one day. But what is one day? Originally, people thought one day was the processes of the sun going around the earth. So right there, we can see that sometimes your intuitive concepts aren't correct. And eventually, we learned that one day was equivalent to the time it took for the earth to rotate about its axis. And today, even though the second is defined in terms of 9 billion something or other cycles for the ground state of the cesium-133 atom, that's still a process. So no one has ever measured time. Every measurement of time has been a measurement of one process or another. And the only progress there is finding processes that are even more stable and more precise.
Yeah, we have a comment here that says it's crazy how the physics community is so convinced time is physically real despite no evidence.
Exactly.
I think another part of it is again with my fascination on my job is really to think about words. I do it every day, programming in that every day. What do people mean when they write these things down? Because we're trying to get the knowledge needed into computers to be able to really understand it, not just mimic it. And one thing about when we're looking at the words that people use and the things and the physical things in the universe, we came up with dimensions as 3 dimensions because we could see that in order to pinpoint something in a space from some other place, we could do it with these 3 coordinates. So the idea of the 3 dimensions people get, X, Y, and Z, whatever. And then because we have the word dimension and we have 3 dimensions, you have the system of language which says numeric value followed by the word dimension. In that, I can plug in any number I want in that. 4 dimensions, 10 dimensions. And yet, and what happened, I think in the 20th century especially, we got off on the track of allowing ourselves to say anything and allow ourselves to try and understand that, because we're free thinkers. We should be able to say the 5 dimensions, the 4th dimension, and then time is the 4th dimension. But at that point, we are straying from the physical world, which is the 3 dimensions came from the physical world. We didn't go out, somebody didn't come up with the idea, oh, there's 3 dimensions. Let me go see if I can find it. Kind of like what most of science is today, right? Oh, there's the Higgs particle. Let's go find it. And so that came from observation. And everybody understood that. The moment we said there were 4 dimensions, whether it's time or whatever, we are now walking from the physical world into the symbolic world of math.
Let me add a footnote to that.
Yeah.
Unlike time, where we never measured time directly, we always measured process length. All of the measures of length were physical length. Like originally, it was something like the meter was defined as something like 1/10,000,000th of the distance from the North Pole to the equator. And then it became a physical bar that was located at the Standards Bureau. And it was only well after relativity was established that they changed measuring length using length to saying that 1 meter is like 1/300,000th the distance that light travels in a vacuum. And they did that so that any measurement, by definition, now has to be consistent with the second principle of relativity, that the speed of light is constant.
Yeah, yeah. And in a vacuum, whatever that means. So, yeah. Okay. So you're saying time is really a process, a starting and an ending of a process.
Yeah, that's the physicality that underlines time. Time is just a generalization in our mind so that it'll be easier to communicate with one another. And as I said in one of my papers, it's much easier to say, hey, I'll see you in 1 second, honey, rather than say, I'll see you in 9,126,358 vibrations of the cesium atom. It's a convenient tool of communication.
Absolutely, absolutely. Okay. Alrighty. Again, if you want to come in and talk or have questions, you can. We're going to continue our talk. If you want to ask a question or make a comment, you can do so in the chat. That way I know. I try to pick them up when I can. But if you put question or comment there and I read it and it's totally civil and everything, I'll put that up. So let's see. Wow. Taking the length and let me look at this, what it says. Wow. So taking length and making that defined by the speed of light really messed physics up.
Yeah, it came about because physics was messed up as well. It wasn't a step forward.
Yeah, it was some way to, I think what they were trying to do in some sense was to take the physical thing out of the picture.
Yeah.
And which is kind of weird.
Step backwards.
Yeah. But okay, let's talk about your work. And I've been wanting to hear about this story. I've heard a little bit about it. Tell us about your finding out about this institute in Germany, and it's what you basically, I think, discovered is they rope themselves into being forced to answer questions that normal physicists won't answer because they know they're loaded and that they will reveal problems with relativity. So they just either ignore you and say, well, little boy, go away. You don't know. You haven't been to the university to be taught this. That's what they usually say. But isn't it true? You found you discovered that in Germany, when they were building something that had to do with Einstein, that they were going to be required by law to answer the questions. Tell us about that.
Okay, you've built it up, but there isn't too much more to the story than that. The Albert Einstein Institute was signaled out by the German government as the authority on relativity, and that any quote-unquote reasonable question about relativity, they were the final answer on that. So, two of our colleagues in Europe and Germany, Jocelyn Lopez, a wonderful German name, and Eberhard Friebe, uh, petitioned the Albert Einstein Institute to define the meaning, the physical meaning of the time dilation equation and the length contraction equation. And the Albert Einstein Institute refused to do so. And that was, I'm editorializing, but I'm pretty sure this is correct, that they knew that if they said, oh, it means that if you go with some velocity, your clock will slow relative to any inertial frame. Your clock will slow, and your length will contract in the direction of motion. So they knew that led to a contradiction. They've had that experience. And that's why they had to come up with the idea about acceleration means I can't use special relativity if I've ever accelerated in the past or will ever accelerate in the future. So that was pretty damning evidence of itself. So Jocelyn wrote me and said, must be some equivalent in the United States of somebody has to answer questions about relativity. And like freedom of information or something like that. And I asked one of our members, Stan Brown, who was a lawyer, and he said, no, unfortunately, in the United States, there isn't an equivalent requirement for academia to answer questions that are embarrassing to them.
That's unfortunate, but that's not surprising.
No.
But so did you? I remember I remember corresponding with her as well, Jocelyn Lopez.
Yes.
I remember that. I think that was in the early 2000s or something like that. And she was active, and I did see some of that. That does ring a bell. Did you ever do any interactions yourself with that institute? Did you ever send them any questions?
Well, not myself, because it was if a German citizen asked a question. So they had to ask it, but I am inquired about that, and they were hoping that I could ask some American institute, and that
Right.
might be required by law. But,
So Peter Marquardt, did you ever meet him?
I don't believe so.
Okay, you would love him. He is an absolutely wonderful person. One of my favorite people ever from the NPA. He lives in Germany still. Doesn't have a lot of internet access. I don't know. Someday I'm going to get some money together and send him a computer or something. Hey Peter, would that work for you if we can get you a computer? We'd love to have you on. Anyways, he says, congratulations to Nick from Germany. Yep, clocks compare and count durations, not to be confused with the abstraction we call time. Again, it's about the meaning of our words. So
let me just, before we get Peter on, let me just make a few points, otherwise I'll forget them. So he uses the word process durations, but some people think, well, durations, that implies time. So it is very tough, because you've got so used to the language of time. And I went on, and in my paper, I showed how duration and rate and other things that are people think of being inherently associated with time are simply measures of the number of cycles in a process. And the other thing I'd like to make clear is, as GPS has shown, clocks do slow with velocity, but it's not velocity with respect to each and every inertial frame. It's velocity with respect to a single preferred frame, which in the case of GPS and their atomic clocks is the Earth-centered inertial frame, the center of the Earth non-rotating frame. So yes, Einstein was right. about clock slowing as a function of velocity, but he was just wrong in his physical model of saying it's velocity with respect to any inertial frame. So rather than having all inertial frames being equal and indistinguishable, what we have is motion with respect to a preferred frame, or as I prefer to call it, a preferred physical entity.
Physical entity. Yeah, here's a
So
person.
there's a world of difference. So the two are opposite ends of the spectrum of physical theories.
Right, right. We're going to put some other comments up here that people have.
Well, bring back
Yeah.
Peter. I interrupted Peter.
Oh, no, no, no. Peter
Oh,
was just, that was
oh,
his. Yeah, yeah. I want to bring him on, but
yeah.
I'll have to talk with him. So, Peter, if you're listening, send me an email. We're going to try to get you on here, whatever that's going to take. If we have to get you a computer or whatever, I'll see what we can do. So, this guy is talking about time. It's interesting to see comments, and, time is malleable, known as gravitational redshift or dilation, just as matter is malleable in different states of matter. Time absolutely has physical presence.
Underneath the abstract concept of time, there is absolutely a physical presence, namely all of the processes that we see. And whatever argument you have about physical time having physicality, it can be shown that that's explained in terms of
The process that you're
physical
looking at.
processes. Yeah,
But
physical
but ti
processes.
I think the problem is in this case, I don't know if this person's saying, I don't want to put words into their chat or mouth, but time absolutely has, when the person says time absolutely has physical presence, you're saying that time is based on these physical processes, but time itself is based on, it isn't the physical processes.
Yeah.
But I think this person's saying that it is physical somehow, and I don't know if that's what they're saying, meaning, but that seems to be what they're trying to say.
Yeah, most people who think of time as being something unto itself think of throughout the world, everything proceeds one tick at a time. But all of our evidence is that how fast something proceeds is dependent upon the physical parameters of its location.
Mm-hmm.
And that would tend to argue against a universal time or a single thing called time.
Mm-hmm. Yeah, for sure. No, okay. We have some people in the green room. Put your videos on. I'm not seeing people's videos. If you do want to come on and talk with Nick, you can, and say hello, make some comments. That would be great. I see. Hey, there's Ian. Ian, won't you? He is. I do want to introduce him, anyways. He does host our alternative Saturdays where we get into nitty gritty. So I can't talk with him too much because he's way smart. I'm kidding. I'm kidding. But anyways, I'm going to add him here. Hey, Ian, it's good to see you.
And you, David. I thought I'd give people a bit of a break from my rambling on every second week. But it's great to have Nick there. Actually, I was just thinking, I think it's exactly 10 years to the month. I think it was January 2019 that I was invited to give a presentation by Greg Vogt to the then NPA. And I think that was probably the first time I met Nick in the discussion, and a few others like Harry and Glenn Baxter at the time and so on. And they subsequently invited me onto their little discussion group. So I think it's 10 years to the month.
Oh, wow. So that's 10 years. Oh, my gosh.
And you're celebrating wildly at that event?
Yes. Well, we're all pushing on in Anno Domini. But anyway, we're still around. And you've been at this, even longer than I have. And I think you've concentrated on this whole business of time quite brilliantly, actually, and your video, your YouTube channel is quite illuminating. And actually bringing in this whole question of Dingle as well is quite interesting, because with regard to the acceleration explanation that you talked about much earlier, I think David raised it. Al Kelly in his book Challenging Modern Physics, he talks about this, and I think he enumerates in excess of 20 possible explanations of the non-symmetry of these clocks, A and B, as distinct from B and A, as Nick talked about. And actually, they're contradictory, but they seem to be just really trying to save the circumstance. And this acceleration business, which could take place in a very, very small amount of time. I mean, you have maybe for years and years, for hundreds of years, or for lifetime, maybe for 70 years, you have the twins going apart, and then he accelerates, he decelerates and then accelerates back. That may take place in just minutes, and that changes the whole question of symmetry. It just seems absurd.
The other thing is that if you have two people doing exactly the same symmetry, but their twin paradox scenario began at very different times, then you're attributing the turnaround acceleration as having very different effects, even though the parameters of the acceleration are exactly the same and in exactly the same place, which is not the case of any other real physics.
So what you're saying is if you set it up differently, now you have another paradox introduced, which is kind of the reverse of the other, where you're kind of starting out and then moving versus then coming together. So, yeah. So it's one of those things, time, Ian, that I think really is something that if you really try to solve that in your own mind as a critical thinker, like yourself or myself, and say, I'm going to think about this, it isn't something that you tackle necessarily very quickly at all. I think it's such a simple idea, but I think what I'm kind of saying is Nick's journey was a long journey in time, in processes that went in his head, because trying to get to an answer with this is not something that's going to it's going to take some cycles to get there. I don't want to say time, but I mean, but I think if you and I mean, I've thought about time myself, but I kind of realized very quickly that this is not something you're going to yourself answer in a quick amount of work or application of what your thoughts. I mean, does that, you know what I'm saying? I think one of the things that makes Nick's work done so well, and you really need, I've watched his entire YouTube channel and all of his videos, is that you realize the journey you have to go on in order to get to understand what even he's saying as a conclusion, because you can see the words, but to understand all those other things to where that is gotten is not a short process.
Now, let me expand on that. During all these decades, I was not trying to get into the philosophical argument about what is time, and I was not aimed at showing that time did not exist or did not have physicality. It was just, after thinking about it for 50 years, I was just led to that conclusion logically, and by looking at the physics. And it came as a great surprise to me, as though it was a eureka moment, but really it was a many-decade process that led me there.
Yeah, I think that's true. Go ahead, Ian.
I was just going to say that, well, two things maybe. One is just quickly, this whole question of philosophy and using language can be fraught. And I don't extrapolate too much from using mathematics. I mean, when one is using mathematics, one can use, the coordinates X, Y, Z, and then T as well. Well, it's a motive to start introducing a term dimension. You needn't do that. You can just say, well, in trying to describe the properties of a particle in reality, you use the 3 dimensions and you use time. The other thing I was going to mention is that, on the philosophical aspect, this thing goes back. I remember attending a lecture on Berkeley's on being embrangled, a nice word, on being embrangled in time, which he wrote in the earlier parts of the 18th century. So he's been at this. But by the way, I just mentioned something in the headlines at the moment over here. Berkeley, which is the original pronunciation, he went over to America, and Berkeley, as you call it, is named after him. He was in Bermuda and he gave money and so on, but in California. But the Berkeley Library in my alma mater, Trinity College Dublin, they want to rename it now because he's a no-no. He had some association with slavery or something, and this has been called the Berkeley Library. Is going to be renamed. So just a bit of woke nonsense on top of other illogicalities. Just mention it.
Yeah, it's
Berkeley, on being embrangled in time.
Yeah, it's something that people really do think about. I remember my mentor, Dr. Carazani. He said, "We don't know what time is." At that time, he said we didn't know what time was, and that someone's going to figure this out. And I think I've seen people really come close to answers. Like Nick was talked about how time to him is something that is measuring proper processes, right? You have a process that's going on. Time is going, and if you look at it, what Borker's saying, it's movement. Well, processes are physical things, and it's their movements,
right?
And so, and you kind of cordon off this thing as these movements are happening, and you see the result of it, and it's interesting that 2 people have come up with very kind of similar things, and both based on physicality, which is really interesting as well. So anyways,
what was even was it Zeno, one of the Greek philosophers, talked about a moving river? You can't step in the same river twice. Now, if that river were stationary, if there were no process changes in the universe, we couldn't calculate time. Everything would be static.
Right. Yeah, a number of philosophers have said that if you had a universe without movement, without change, there would be no construct of time.
Well, there'd be almost nothing, right? I mean, you can't even make perception, because perception, even in the brain, has to have movement of stuff. So you couldn't.
Even if you were looking at it from the outside, you would.
Right.
They were saying you'd have they'd see a timeless universe. So it's really changed that people are translating into passage of time and the flowing of time, etc.
Okay, well, thank you very much, Ian, for coming on.
Thank you very much.
And remember, thank you. Oops, wrong one. I always push the wrong one. It's all right. So, Harry Ricker is here, and he's making a comment. Processes measure time. They are not time. Special relativity confuses the change in process with the change in time. Do you understand what he's saying?
Yeah.
Or
yes, I think I'll have to send Harry my paper on time does not exist.
yeah.
It's just a generalization of processes. That's because we've never measured time directly.
Yeah, it's kind of part of the way we, how do you say, we use physical processes. Time in reality are things we build, physical things we build, that we look at the state at some marked point, and it goes for another marked point, and then we give those things numbers, right? I mean, we give those.
I do agree with Harry's second statement. Special relativity confuses the change in process with change in time. Yes, that's true. But we just interpret what the confusion is a little bit differently.
Right. So in the end, when you look back on your work that you've done, obviously I will say that I would imagine. Do you remember what year more or less you were contacted by Greg Volk?
He saw my paper in Physics Essays, which was 1992, so it must have been sometime, a year or two afterwards, or something like
Really?
that.
Because yeah. Maybe it was later though. I don't
Yeah,
know.
he might have discovered it later.
Yeah, I remember he and I in the 2008 when we were building the database of all the world scientists that ended up in our wiki, and our wiki.naturalphilosophy.org. Check it out. He was we would go just nuts. We were scouring the internet to find stuff.
Wow.
He and I were like, were we were built. I built the database with PHP and MySQL, and I built us a homegrown database to enter data. And he and I, for 2 or 3 years, just built this entire thing that is now 10,000 pages of stuff. And he has his house full of documents and papers people he's
Yeah.
gathered and paid. And one of the things is we found a lot of people, and he found you by us looking. So it was really a search, I think, that got us into these things. And Greg Volk, of course, and I were very hell bent on trying to find people.
Yeah,
So
that triggers a thought, because I think for 45 years or so, I really was a loner without any outside influences. Even though I read Dingle, he simply confirmed what I had thought. And I think that was a great advantage, because I think if you're in academia, you're subject to group think and group pressures. And in a way, you've studied it so hard for so long, it becomes a strong belief system. And
right.
human beings, including dissidents, once
Yeah.
they've got a strong belief system, it's going to be hard to shake, no matter what's put in front of them.
Right.
And maybe that's good, because we don't want people abandoning a theory that has some validity just because someone comes along and say, "Hey, this part's wrong." So,
Sure.
but when Greg brought me into the NPA, and I was exposed to a lot of different people outside of academia who had different perspectives, then that really was stimulating to my thinking. So it was good to be alone for a while, and then it was really great to be
what's
part of a universe. And I think when I did the twin paradox study with a lot of colleges and whatnot, I could never have done that as an individual. I had the gravitas of being part of a very large group.
Right. Somebody asked, can you join the video? You absolutely can. Go to live.naturalphilosophy.org on your computer, and that will take you to the StreamYard and get in. And yes, it is working because people are joining. Normally, if you have watched these regularly, what will happen is your browser will cache, meaning save the address for a domain, because it's trying to be clever and do things without going out in the internet and finding on your server which place to go for a domain. So be careful. You may want to clear your cache, hit an F5, or even better yet, you can go to your browser, go into an incognito version, which does not remember anything, and you will get here. So you want to try that. I know I see Jim Marison and Franklin Hugh. Did you want to come up and at least congratulate him and say something to Nick on this day of his Lifetime Achievement Award? So I know Franklin's here. So hey, Franklin.
Yeah. So congratulations, Nick. Well deserved on your Lifetime Achievement.
Hi, Franklin.
Although it seemed
Thank
pretty
you.
obvious that the twin paradox doesn't work, but I wanted to anyone should be able to figure that out. Now, my only question is, why is it we're still talking about this? People should have just saw that and said, but no, that's the actual paradox, because that's what paradoxes are supposed to do. They're supposed to show, well, that can't be right. It's obvious.
Yes.
But I wanted to talk about, you just sent a mail out about atomic clocks slow with respect to the Earth-centered frame. Now, I think this is very interesting. I just made another reply, saying that this seems to be one of the most important things to observe, that when it comes to, say, the time dilation formula, in order for it to be calculated correctly, we have to just presume that the center of the Earth is the absolute stationary reference point when you calculate everything on.
Locally.
So, yeah.
Within the vicinity of the Earth, not necessarily the whole universe.
I'm not sure whether it's in the, that's what I want to ask you about that. It's like, is it within the vicinity of the Earth?
That's where the data, that's all of the data that we have.
Yeah, that's all the data we have. So I kind of propose that, like, if we were to like send a GPS satellite, say, around the sun, and we wanted to, calculate it so that it would be in sync with what's on the Earth, like we do with all the others, but we still have to calculate it as if the Earth was the stationary point.
Yeah, the assumption by myself and Ron Hatch was that it would have to be around the barycentric point of the universe.
Well, maybe, but that's what I was kind of asking you. Maybe because some people are thinking that, well, maybe it's a CMBR defines the absolute reference frame of the Earth, but it's like, as you said, for all the data that we actually have, particularly the GPS and things like SIGNAC, it's like the calculations are done as if the center of the Earth was like the center of the universe, right?
I think here's an interesting thing that you're talking about is the way you can look at the center is every time you enlarge your circle, you're going to be able to find kind of a center in some way, right? And if you were to enlarge your circle to galaxies, then you can say, okay, how are the kind of, look at all the speeds. The more you include in your Venn diagram, the more you can look, your locality just gets bigger, right? So, but it doesn't tell you, because every time you pull out of that something, you could put something in it that's going in it completely different. So it is still locality, but it depends on the size of your locality.
Well, yes and no, but I think the more important point is Einstein's all physics is local. So, like, it might be that its velocity with respect to the non-rotating gravitational field.
Yeah, you do mention that, so get your ideas on, if we were to, I don't know, like set up GPS, say, around the sun, and then might we also find that to those satellites, it seems that the Earth, the center of the sun is the
right.
Right.
Yes. So in that locale, then you have a different preferred frame or preferred physical entity. Yes.
I'd be interested to put a GPS satellite around the moon and see what it thinks the correct frame is. Would it still be the Earth? Would it be the moon?
Or the center of gravity between the two?
Oh, yeah. This is one of the things we always talk about is only one thing, right? We talk about two things, a twin. Then you get to triplets. Yeah. Then I tell people, I go, okay, you believe in inertial frames. Everything that's moving has an inertial frame. Okay, take a person sitting down, not moving at all. Now go to each of their atoms.
Yeah.
And now you have movement everywhere. Even things that we think are stationary aren't movement. And if every one of those has if you take a body, you put a frame on it, you say that's stationary. Well, within that body, you have moving things, processes going on. So then you got to put frames there. You just get into an infinite amount of problems and relativistic problems, right?
Yeah, that's why we need to, set the center of the Earth as the absolute frame. And if you thought about it, that if that were true, then it's obvious that the person who's sitting at the center of the Earth would age the fastest because they have relative velocity of 0. The person sitting on the surface of the Earth, like one twin, would be aging slightly slower. And then if you send twin B off into space and he comes back, he's going to be even slowed down even more, because all of these calculations are done in an absolute frame. And that's the only frame these things make sense. Otherwise, this is the problem that Nick pointed out, is that you can't. You can't have this is the absolute frame and that's the absolute, and they can't be the absolute frame at the same time. But things
it's a mess,
easier if you just pick one. So And
Well, that's what happens. That's what happens with GPS.
I
So
think it's peculiar that the GPS satellites seem to think that that point is the center of the Earth. So
yeah. If you pick another inertial frame that's different from the ECI frame, the more different it becomes, the greater your error is in the GPS system.
right.
The ECI frame is to the least degree of precision, and it's very, very precise. It's the ECI frame. That's
so
the preferred frame.
Other people have proposed, this is a space experiment we need to do. We need to send atomic clocks like way outside the orbit gravitational influence of, say, Earth, and check it out. I mean, it would be very surprising if we did that and we still found out that the Earth was the proper absolute reference frame. That would be very surprising.
Absolutely. Yeah.
Yeah.
It's
okay, Franklin.
dependent.
I'm sorry, we're coming to the end here, but I want to put a few other people up there. But again, you can catch Franklin too on the alternative days. He's always around hanging, and he's hosted these. So thank you, Franklin, for coming up. I want to put up a few other people here.
You had a question from Martin something S.
Yeah, I think. Well, he had a bunch of says. So the center of the Earth is reference the origin of coordinates. How does it cause the clock rate to change with different radius from the center?
Ah, love that question.
Okay.
So let's say that you have two phenomena that affect the speed of an atomic clock. One is velocity with respect to the Earth-centered inertial frame. And it occurred to me that maybe that's the physical thing is the gravitational field.
Right.
But as the gravitational field weakens, that has an effect on the atomic clock as well. So maybe they're really the same effect. And what happens is when you increase your velocity with respect to the gravitational field, you experience the gravitational field as if it were getting more dense. Mm-hmm. And you sort of simulate a change in gravitational potential.
Right.
So
but there's still physical.
That question, yeah.
There's still physical changes, right? I mean,
physical changes.
Yeah. One of the people don't understand is that I think one of the myths was, even when they made them, was atomic clocks aren't physical. They're not going to be affected the same way. Because if you put a pendulum clock outside of gravitational field, it stops, right? The pendulum will go, but it's not going to come back. Or it's going to be all screwed up. But that's the gravity. It's affected by gravity. But because atoms make up what we make clocks out of, even if it's an atomic clock, it is still affected by gravity. So, okay, I've got a couple other people in the green room. I've got Jim Marison and also Frederic. Did you want to come up, Jim, and say a few things, or were you okay? Just wave to me if you want to say hello. Yes, you do? Okay, I'll add him. There you are, Jim. So.
Hey, can you hear me?
Yes, we can.
Oh, great. Yeah, I mean, Nick, congratulations.
Thank you, Jim.
You well deserve it, especially since you understand about the ECI and GPS. You're halfway there. Now all we have to do is do it for the Michelson-Morley experiment. Because if you put I mean, like I said in my comment, that's the key to disproving Einstein, since that's what led to it in the first place, the special relativity. So if the ECI is the preferred reference frame for Earth in the vicinity of the Earth, then it explains why nobody's had a positive result for Michelson-Morley on the Earth, because the only velocity, but there is a velocity, it's the velocity of the rotation of the Earth,
right,
with respect to the ECI, and that's much, much smaller than what was looked for by any of the Michelson-Morley experiments to date.
Yeah, but also Michelson-Morley is assuming there's an ether, which is one model.
Well,
So
I mean, just take out the ether. Let's forget the ether for a moment.
Right,
Just
exactly.
talk about an inertial reference frame.
Right,
Okay?
exactly. No, I see what you're saying. Yeah. So if you take away the idea of you're looking for ether and you're just doing the measurements itself, that's what you're saying. Then yeah, it
I
seems
mean, I happen to believe in ether, but I don't want
right.
to argue with you about it at the moment.
No, I understand. But what I'm saying is, like anything, you have a physicality, and your assumptions as to what's happening are based on the physicality of what you
Okay.
think is going there. But what
Okay,
you're
what I'm
saying is,
trying to say is,
without the ether, you're talking about just the apparatus and the measurement, is right?
okay, whatever. But the point is that if you take it up uh, on a satellite in low Earth orbit,
Hmm.
your velocity with respect to this ECI is much higher than uh, what's due to the Earth's rotation at the surface of the Earth, and you're much more likely, and I predict you will, get a positive result. And then Einstein is dead. Special relativity is dead.
One caveat is that, rather than talking about frames, we talk about velocity with respect to some physical entity. And it may be that there are multiple different preferred frames for different physical phenomena.
All right, so I have
this is a clock slowing phenomenon, and it might be a different preferred frame for light propagation.
I have an
try to keep
explanation
an
for that too.
open mind on that.
I have an explanation for that too, and I suggest you look at C.C. Su's, Ching Chuan Su's local ether model, which does explain how the energy of an atomic transition of a cesium atom is affected by the gravitational potential and the velocity of the atoms with respect to the ECI.
I think didn't you talk about that on
In previous,
yeah. You should check that out, Jim. Type in.
Throwing it out again here.
No problem at all. No problem at all. So if you check out this channel here, the CNPS channel or Dissident Science, you can look up Jim Marison and talk about that.
I have a channel that has a video that talks about why we should do
right.
an MMX in low Earth orbit, or even better in interplanetary orbit, where you'll see the full. Sorry, I'm trying to get this out fast.
No, it's okay. I got you. Yeah.
Velocity of the orbital speed of the satellite,
right,
at 30,000 meters per second, that people have been trying to find on the surface of the Earth for 100 years.
Okay. Well, listen. Thank you, Jim. I want to bring you down, but thank you so much, and it's always great to talk with him. And
I've read some of Jim's papers; they're very good.
Yes. Okay. I got another person, Frederic. Are you there?
Yes. Hello, everybody.
Hey, how's it going?
I'm very, very glad to be invited in your video. Congratulations to Nick for this award, and I have to thank also David. And please excuse me for not giving news for so many years. And I was working also with Greg very long ago, maybe 10 years ago. He was so nice to me for helping me writing my papers at the time. So please, okay. So I thank you also for the CNPS and all the work you are doing, David, and all the team. And
yes, in fact,
Nick, but yes, please.
Yes, I mean, I remember you very much. I know your name just by looking at it. When I see names, I recognize and things flash up. You can search Frederic's name, and I can see you have some work out there. You've got a YouTube video on the gravitational model of three bodies, or what is that? The three elements theory. Yeah. So there's a lot.
Yeah, this is an old work. No. It's much more precise research work, I must say.
Right.
Okay, but the topic you are talking about today, from my point of view, is extremely important. And the key, those are really the key questions in today's physics.
Yes, and I think, Frederic, maybe you would agree that mainstream physics doesn't look at this at all. They don't.
Yes.
And that is such a huge problem. But of course, there's so many huge problems. One problem leads into another, but you don't hear this type of conversation anywhere.
Yes, because on the mathematical basis, you've got an explanation. So you see, it's always the same phenomenon. When you have one mathematical explanation, then everybody thinks that the problems are over. You see, so it's not the case here, because with the twin paradox, even though you've got one mathematical explanation, nevertheless, there is still something to be found here, and that's what I try to show in my personal site. But I don't want to talk too much about my work.
No, but we
Because,
need to.
we are
So
here
what I'd
for the
like to
work
do
of
is
Nick. Sorry?
like to do is to have you come on and talk with us one week. So
Yes, please. Yes, I
let's
would
do
be
that.
very, very pleased to do so.
Okay.
So please, David, please let us contact us about that later
Okay.
on behalf of this video.
So are you in Europe?
Yes, I'm still in France. Yes, I'm still
Okay.
in Europe.
Okay. All right. Well, listen, thank you very much, Frederic. It's great to see you. Again, check out his work, and hopefully you'll have him on to talk about it. But thank you very much for coming on.
Yes, I'm very, very glad to talk to you. Thank you very
Okay.
much.
Thank you.
And,
Thank
thank
you.
you, Denis, for your work.
Okay.
Of course.
So
That
many
reminds
people.
me that
Go ahead.
when we were, particularly when we were in the NPA, we would have people come on and give presentations of their work, like doing some experiment or having some satellite. And they would always say, we tried to use special relativity, but it didn't work.
Right.
To get something to work, that's where when you get to engineers, then you have some capability of convincing them of what's a better model.
Yeah. It's absolutely true. I think one of it's we have so many people around the world that are really trying to dig into all of what we've been talking about. And I think a lot, what's interesting to me too is just to kind of sort of wrap it up is how when Greg Volk and I spent time going out trying to find people, how many people there were. And one of the people that I think gave a statement about especially relativity that kind of hit me and I use all the time now was Glenn Borker. He said, relativity is the most disputed theory ever created. It's the most disputed theory out there. And if you ask people, of course, in mainstream, it's not. But if you look on our website, I think we have over 2,000 books and papers written on the problems with relativity. And so, like you said, what I tell people is that if you are a real critical thinker and you really have the open mind, almost anybody I respect their opinion that they are critical thinkers. We have certain people that if they say they've looked into something, I kind of think they really did, and I still listen to them, but all the people that I know that I really think are really great minds who have looked at relativity have come away with the same problems in many different ways, but the same problem. My father was one of them. In 2013, at the premiere of my film Einstein Wrong, I knew he didn't think Einstein was wrong because he didn't look into it. And I asked him right in front of the entire audience, just as a joke. I said, I know, Dad, I'm going to ask you this question. I know the answer. Do you think Einstein's wrong? He says, I don't know. I haven't looked into it. So I think what I always tell people is look into it yourself. Take some real time to think about what's really going on. Don't read papers about the explanations for it. So anyways, we're wrapping up here. We've gone over a little bit, but I want to again thank you and congratulate you once again on the Lifetime Achievement Award. It's really, really merited. We have a lot of people in the critical thinking and dissonant world that deserve this, but there are only a special few people that I consider and our organization considers to really have contributed, and you have definitely done that. So thank you so much, and if you want to say a few last words before we wrap up, that would be fine.
Thank you a million times over for this award and for the work you've done to keep the NPA going and then make the transition and keep the NPA going, because at least you had Greg Volk helping you in the days of the NPA, but now, unfortunately, all the work lands on your shoulders. So.
Yeah, well, I think eventually we're going to get somebody else. I remember walking into the organization in 1996 at Flagstaff, Arizona, and seeing all the people and remembering all the people of the MPA early on, John Chappelle and all those people, just a ton of people. I remember, a guy getting up, giving a talk. I think he was 96 or 97 years old, could barely get up and talk, and he talked. And I go, who is this guy? And he goes, oh, that's the guy who pushed the button on the first atomic bomb. And it's like, whoa. And he was talking about distortion and how the physicality of all that. And I've been really lucky to be around people and like yourself, and I've learned so much. I just don't want to see it die. It's not easy at times, at times I want to just chuck it, but even yourself, I want to thank your support and everybody else. And, well deserved in all aspects. And we're going to keep going. I'm sure somebody's going to come along. I met somebody there was in charge, and was a couple of people in charge. They were my age. They were like now in their early 60s, and, they were running it. So my hope is as we get young people in here, this will continue. But thank you and congratulations. I'm going to say goodbye for you now. But
when it comes time for your award, it's going to be like cat. It will be a
20 years from now.
Lifetime.
No. I know.
You wear so many hats.
But anyways, there's a difference between, helping it out and actually doing the scientific work. What we do in the CNPS is really more scientific work. So your work is really very special. Thank you so much.
Thank you.
Okay. So thank you so much, everybody, for tuning in from Nick. Again, check out his channel. Give him support as well. His channel is really well worth looking into. If you haven't seen it, just go to this address, nick.naturalphilosophy.org. It'll take you to his YouTube channel, and you can watch his YouTubes. If you are really an uber nerd who really wants to listen and understand more about time, check him out. He really, his work is stellar. So let's go, and we've gone over time, so let's get out of here, folks. Oh. Oh my goodness, in the new age where you do everything, the production, the whole thing, you double click a button and you're caught off guard. But listen, like I say always, don't believe what I say or anybody else here. Take your time, stay critical, stay thinking. I'm David de Hilster, trying to get you to the promised land, like our organization, to become a critical thinker and think on your own. Ciao for now, folks.